third session of 2022, and thanks everyone who are joining from different parts of the world. So good morning, good afternoon, good evening to everyone. So before we just hand it over to Matt, because we are already running out of time, but just a quick view on like this Power BI, this user group runs sessions from different areas of data platform. You can see we have got some sessions running over Power BI, Excel, Power App, and everything else. So we talk about everything related to Microsoft Data Platform on this group. So today we'll be just showing you a few things, like our sponsor is Enterprise DNA, and then we'll have some winners to be announced based on the last session that this user group organized. And then we'll be talking up quickly about our current and upcoming event. And then we'll start with the Q&A session. So first of all, a very big thank you to our sponsor, Enterprise DNA, and it's very big platform where you can find too much about every other Microsoft data platform, whether it is Power BI, Power Query, Excel, Power Automate, anything. So just go and visit their website, and they are actually giving 3 free annual Enterprise DNA membership each month. So we'll be drawing 3 users, just in few minutes. And at our user group, we have got so many members so far. And so thanks for your love, guys, and keep, joining us at these sessions. And the other thing is this is Enterprise DNA website. So any of you guys, if you're interested in the things or the available courses available there, just go and see them because they are really good courses over there. You'll definitely learn a lot from there. So before anything, we go further. So our guest today, Matt Allington, he has got an amazing book, Supercharge Power BI, which is a great book to read about. So if any of you guys who are Power BI enthusiasts, then please go and read this book. It has got too much about Power BI, everything you need to start your journey with Power BI, along with DAX, because DAX is something really not easy to handle. So Matt has really got it done in the right way on this book. So do check out his book here. Then obviously, it's a great honor to have Matt today on our user group. And obviously, this is my first hosting session, so I'm so honored to welcome Matt on this group. And today, Matt will be talking about thinking about DAX functions differently. And Matt is an MVP, he's an author, he's founder of Accelerator BI as well. So if guys, you really need some BI content, go to his website and check the content because he is up to mark on everything on his website. So you'll get so many helpful tutorials to start your journey, advanced tips and tricks, everything. So just go and visit his website there. So before I hand it over to Matt, just a quick thing. I just want to raise one thing here, that the next speaker that we'll be welcoming, Melissa Coates, on 24th March, and she'll be talking to us about what you need to know to administer Power BI. So that's just a quick reminder. If any of you guys are interested, please go and register for the event. Then quickly, we at Baku Power BI Group, we have got our own YouTube channel. So we record all the sessions. So any of you guys, if you missed the sessions, you can definitely go back and check the YouTube channel. So we have got all the recordings available there. And it's time to define our winners. So Ilgar, over to you.
Okay, thank you. I will take just 2 minutes to define our winners among the participants who participated in our previous meetup session. Actually, as you may see, roughly 95 people have attended this session, but not everybody has his, email address, or not everybody has attended the event more than 30 minutes. So the number of these people who just covered these, conditions are 10. If I'm not mistaken, yes, it's 10. So I'm just going to use simple Excel functions, including rand between and index to define our winners. Just as I'm clicking on F9 button, it's going to randomly choose the winner's name. As soon as I'm release my finger, so 3 people's name will be appeared here. It's very possible that the same name will appear. If this takes place, in this case, I will just do it again. So I'm counting back 3, 2, 1. So these are the people who can be defined our, winners. If I'm not mistaken, Claudia Rojo is also participating in this event. So I will send you the email addresses, and I will send you the necessary information after this session, and you will have full access to the great content of Enterprise DNA. So stage is yours, Pragati, and we can invite Matt Allington to start this session. Thank you.
So Matt, yeah, it's over to you now. And just one thing, Matt, how would you like to take the questions? I mean, do you want them to be taken in the end, or have you got any breakpoints in your session?
I do have a number of natural breakpoints, and so I'll do a demo and then a slide summary, and then that would be a good time to take questions, I think.
Definitely.
So, but look, I'm pretty flexible, so hopefully. Now, let me see
definitely, Matt. I mean, if you feel like you have got some breakpoints, then let's take a few questions there. And if you want them in the end as well, it works for us. Yeah.
All right, good.
Over to you, Matt.
Okay, so can you see my screen okay? And we'll get started.
Yes, can see your screen.
Excellent. All right, well, hello, everyone. Thank you very much for the opportunity to come and talk to you tonight. I see some names. So Christian, hi, Christian. Christian comes to every presentation I make, no matter where it is in the world. So Christian, I'm glad that this one is at a time that's perhaps a little bit better for you, but to everyone else who's joined as well from all around the world, thank you very much. I won't spend a lot of time on myself. You're here to hear my talk rather than my introductions, but I think the key thing I'd like to point out on this page is that I'm a business person, right? I spent my life working at Coca-Cola. I'm not an IT person. I'm a business user, an Excel user, if you like, who discovered Power BI. And so there are many people like me in the world, and Power BI is one of the best products for people like me and for people who like me, who've got sort of an Excel background. It doesn't mean it's not a good product if you have a SQL background. That's also fine. But it's a wonderful product if you're coming from an Excel world. And your user group is the modern Excel user group as well, so very appropriate. As Christian pointed out, I have got a third edition of my book. It's the black one. So if you get a choice, if you do go looking for my book, check out the black version, as I call it, which is the latest version. Okay, so here's the agenda. So I'll do a brief intro, and I'm going to talk about the DAX language. Now, this is all about DAX, and hence the topic. I'm thinking about DAX differently. But what I want to do is I want to give you some concepts that you can some small, simple concepts that you can understand so that you can step your way logically through the DAX language. And I've been teaching DAX for 8 years, and I've learnt how people learn DAX, if that makes sense. People learn in very similar ways. And I'm going to try and simplify some of these things for you. So we'll talk about measures, calculated columns, and tables, and then I'll get into 3 demos using the techniques that I cover in this first session. So that's the high-level plan. It's going to be mainly demos, but I do have a couple of slides just to call out a few key concepts. Now, I'm sure you know data analysis expressions. That's where the name DAX comes from. The first thing to know is that DAX is a functional language, right? So now what I mean by a functional language is like Excel has a functional language. So Ilgar, when he just did his draw, he did a rand between function, and a function has a name, it's got some brackets, and it takes a number of parameters. So that's what a functional language is. So Excel is a functional language, so is DAX. And that's deliberately a functional language, because when they invented the language, they were thinking about Excel users. People like me, maybe people like you, or certainly other Excel users in the world. So there are other languages out there. So SQL, for example, the database SQL uses a language called T-SQL, and that's a scripting language. It's a very different type of language. And so you can use the DAX language inside SQL Server Analysis Services Tabular, which is a bit of a mouthful, but it's a database. DAX is a database language. Excel is a spreadsheet language. They're not the same thing. And hopefully I'll sort of cover some of those differences, and you'll lift your understanding. And so I guess one thing that you need to be clear of very early in your DAX journey is, are you generating a formula that will return a single value? Or are you generating a formula that will return a column of values? Or are you writing a formula that will generate a table of values or strings and stuff? So there's 3 definite use cases, and I'm going to show you all of those and help you understand the differences and how we can use that. So, okay, so with that in mind, let me jump over to my favorite AdventureWorks database. So I've got Power BI Desktop open here. I call this database AdventureWorks 2020. I'm sure most of you will be familiar with AdventureWorks. It's a chain of bicycle stores. They have sales. If you walk into the bicycle store, you can grab a bike and a helmet, go to the cash register, pay for the bike and the helmet, and that will generate 2 transactional records in the sales table. And then we keep a whole lot of information. Who was the customer? What date was the transaction? What are the details about the products that you purchased? Which store did you buy? So that's the basic. And this is a simple star schema data model. DAX and Power BI were built for a star schema. So wherever possible, you should be aiming to have this type of structure. It's not always going to happen, but that's always the aim. All right, so let's talk about these 3 different types of ways you can write DAX. And so first of all, I'm not going to write any DAX at all. So this is a card. And if I open up the sales table, I've got this column here called the extended amount column. Now, I'll do a bit of jumping around here, but if I come back to this table view and I'll go to this extended amount column here, what I want you to note is that it's a column of values, right? So it's a column in a table, and that column has many values. In fact, if you look down here, you can see it's got 60,398 values, because there's that many rows, one value in every row of the table. And so I can take that column of values, note the sigma here, and when I drag that into my card, I get, in this case, it's the total, 29.36 million. That is the total of all of the values in the extended amount column. But what you need to appreciate under the hood is that when I drag a column, Power BI has made a deliberate choice. Now, I'm zooming in. Can you just tell me, maybe just someone unmute and let me know, is that zooming in for you? Because sometimes Zoom doesn't zoom.
Yes, Matt.
It is zooming in. Okay.
Yes.
Excellent. All right. I'll just try and do that just to make it a little bit easy to see at appropriate. Thank you for that, Pragati. Okay. So what's important to understand is that you can't, or you can, a column of numbers, you have to do something with the numbers. You've either got to add them up, or you have to count them, or you have to find the largest number or the smallest number. I'm sure you can appreciate I cannot put 60,000 individual numbers in a card. A card only holds, it can only display a single value, right? And so the leap that you need to take when you move from Excel to Power BI is that when you take a column of values, it's not putting the column in the table, it's aggregating the column. And as a result of that aggregation, it's giving you a single value response. In this case, it's the sum, 29.36 million. But if I took the average, now this number is the average value of all those numbers in the column. And if I came down here and did max, this is the largest value in the column. Now, look, some of you might find this remedial, and you might say, yeah, of course, I get that. But believe me, these are the principles, these are the foundation principles that will help people understand the DAX language. So we call this an implicit measure. When you take a column of numbers or values, you drop it into a card. By default, Power BI will sum the number, but you can choose to do something else. But of course, we want to learn the DAX language. And so instead, I recommend people write measures. So I'm going to right click on the sales table. And now instead of implicitly dragging the column and letting Power BI do whatever it wants, I am going to explicitly send the instructions using that functional language, right? So total sales is equal to, and I'm going to use the sum function, which is almost the same as Excel. and I want to sum the extended amount column. And so you should be able to understand that this is exactly the same concept as dragging the column across. But once I've written this measure, I can come here and put formatting. So I'll go currency general and I'll change the decimal places. And then after I've done that, I can remove this extended amount. I can bring my total sales in. And I'll come up here and I'll switch this to turn off the number display. And so I've got the same answer as before, but the key things that are different, I've got a much better name. Total sales tells me what this formula does. It gives me the total of sales. I've explicitly written the formula to do what I want, in this case, to add up the values in the column. And I've also got the formatting, the number formatting that I want. So there's 3 good reasons to write a measure versus dragging and dropping those numbers across. All right, so that's a measure. A measure returns a single value. Now, it gets complicated because if I was to turn this card into a table and I can bring product category into that table, now instead of seeing a single value, I can see 4 values, right? I can see 1 value for each of the 3 categories plus 1 value for the total. Now, what I want you to be clear on is that these are still single values. Don't confuse this table, this one here. Don't confuse this table visual with the concept of a DAX function that returns a table. That's a completely different thing. So the measure returns a single value. In this case, we're using a visual that sends a request to the database 4 times. It says, please fulfill the request once for bikes, once for accessories, once for clothing, and once for everything. So this is not a column, it's not a table, it's a single value. And in this case, that single value has been requested 4 times by the visual. Okay, so I hope that makes sense. Because it can get confusing. All right, so that's a measure. A measure returns a single value. All right, so let me come over and show you a column now. So if I come to the sales table, I've got a sales amount column here, and I've got a tax amount column, but I don't have a column for sales including tax. Now, I can create a column. I can create a new column by coming here to the sales table, right-click new column. So previously I did new measure. Now I'm doing new column. I am still writing the DAX language, right? So this is still DAX, but this DAX is not going to return a single value. It's going to return a column inside a table. And so I'm going to call this total sales including tax. And this is still DAX. I just say, give me the extended amount column and add it to the tax amount column. Now, this is very similar to Excel when you write this formula. If you had a table in Excel and you wrote a formula like this, it would work. I hit enter. One thing to note is that I did not copy that formula down the page, right? This is one of the key differences with Excel. I wrote a single formula, but I did not copy it down the page. Automatically, that formula was calculated for every single row in the table. This is the way the DAX language works when you're writing a calculated column. One formula, but you're getting multiple results. In this case, there's 60,398 individual results that gets returned, all right? So that's a calculated column. And the one that we did over here was a measure which turns a single value. All right, now the third thing that we want to do is I want to do a table. Now, I'm going to just do this as a demo. I can't remember what I actually was planning to do. Just let me have a look. So, okay, so I'm going to launch DAX Studio now. So DAX Studio is a third-party tool. And I'm going to write a DAX formula in order to generate a table of data. Now, this is different to what I did before. So previously, I was using the visuals, right? I grabbed a visual from the from the visualization pane, it was the visual that generated the structure of the table, and it was the column that generated the category, and it was the measure that generated the individual value. So that's what you can do in the reporting canvas. That's not what I'm doing now. What I'm doing now is I'm using DAX Studio as a scripting language in order to generate a table. Now, I'm not really going to spend a lot of time going into this. I just want to basically show you that you can do it. So I can come in here and I can say evaluate, and I want to generate a table. And so I might write something like summarize. So this is DAX as a query language that I'm doing here. You may or may not have heard of these functions. I want to summarize the sales table. Let me just run that. I think I need a parameter and grab the category, sorry, the product category column. So let me come up here, product category, and I close that bracket. I'll zoom out so you can see what happens. When I run this query, notice down here that I've generated a table. In this case, it's a table with 1 column and 3 rows. Okay, so now I've got a table. I can add some more columns to that table. So I can also give me total sales value, and I'll use the total sales measure, which I generated before, to populate that new column. So if I run this query now, you'll see that that DAX query that I've written has actually generated this table. Different to the measure in the visual, this is actually a physical table, if you like, of numbers which has been calculated. This is a very close match to T-SQL if you've done any SQL coding. All right, now I'm doing this in a tool called DAX Studio. The reason I'm doing it in DAX Studio is because this function generates a table, and you can't generate a table by going new measure or new column. If you do a new measure and a new column, you're not allowed to generate a table because a table is a 2-dimensional object. Okay, so I'm doing it in DAX Studio because I'm basically generating this 2-dimensional object. But what I can do is I can copy this code. I'm going to leave the evaluate statement there, but I'm going to copy this code, Control-C, come back in here, and there is a button up here. So we've done the measure, we've done the measure, we've done the column. Now I can do a new table. So these are the 3 ways that you can generate a DAX formula, or you can write DAX. So I'm going to generate a new table, and this will be, I'll just call it my summary table. And I'll paste in that bit of code that I wrote inside DAX Studio. And when I generate that, if I come back over here, I've actually got a physical new table in my model. And in fact, if I jump over here and go to that physical new table, you can see that it's exactly the one that I generated inside DAX Studio before, which is very different to the one that's on the reporting canvas. So one is a report, another one is actually a table, which is part of the data model. All right, so look, that's the foundation. Let me just summarize what I've talked about, and then I'll just check whether there's any questions. I can see some stuff in the chat. So just to summarize, there are 3 different ways you can write DAX. So you can generate a measure to return a single value. Don't forget that if you have a visual that requests more than one use of the measure, it will get calculated many times, but that's still a measure returns a single value. Then a column returns a number of values inside a new table. And then finally, you can use DAX as a query language to generate a whole new table as part of your model. Okay, so I'm going to just pause for a second and let's see what sorts of questions we've got there, if any.
We haven't got anything so far, Matt.
Okay, lots of chat, so good. All right, so good. So that's the foundation. So let me move on. And I'm now going to talk about 3 different DAX functions that leverage those principles that I've talked about. And so the first one I'm going to talk about is the SumX function. So this is a relatively, I'd say it's a mid-range function. It's not simple like a sum. a little bit more complicated. There's a bit to learn about it. But what I want to introduce to you today is that you should think about SumX as being just like a calculated column. So that's the thing I want you to take away. SumX is just like a calculated column. So let me get into my demo and show you that. So I've already created a calculated column. So I'll come back to my sales table. Here's my calculated column. So I wrote this formula, as I said, take the extended amount and add it to the tax amount. Because I wrote that as a column, then it's valid syntax, and the column generated all these rows, and these rows are permanently stored in my table. Now, if I try, I'm going to rename this. I'm going to call this column, because I'm going to have two very similar DAX expressions. So that's the first one. So now I'm going to copy this code, exactly the same code, and I'm now going to generate a measure. So a new measure, I'll put it in the sales table, and I'll paste what I just had, but I'll call this measure. And notice immediately I've got an error. And so this can be quite confusing to people as they get to learn the DAX language. And the reason there is an error is if you think about what this is a column. Remember I showed you before, this is a column of numbers. There's 60,000 values in this column. And this is another column of numbers with 60,000 values. What this function says is take all of the numbers in the extended amount column, of which there are 60,000, and add that to all the numbers in the tax amount column. But you can't do that because these columns are effectively a two-dimensional object. A column is a long, skinny thing with lots of numbers in it, right? You can't add those two concepts together. If you want to add them together, you could do something like this. Sum, first of all, add up all the numbers in the extended amount column, and then add up all the numbers in the tax amount column. And then when you got those two numbers, then add them together. That will work. Okay, and so I call this error that I showed you before, this one here. When you see this error in DAX, get rid of that bracket. I call this the naked column error. It says a single value for the column in the sales cannot be determined. Every single component inside a DAX formula must return a single value. Remember, that's the first thing that I mentioned in the presentation. Every component of a DAX measure must return a single value. This does not return a single value. It returns 60,398 values, and that's why it doesn't work. I have to do something to that column to turn it into a single value. So I could say sum, I could say count, I could say min, I could say max, and so on. Okay, so that's the first thing that I wanted to say. Now, the second thing is to come back to this SumX. And remember, what I want you to think is that SumX is just like a calculated column. And so I'm going to take exactly the same code I used for the calculated column, and I'm going to say SumX. Now, when I type SumX, look at the IntelliSense. The SumX, the first parameter, it says, give me a table. Which table do you want me to operate on? Now, when I added the calculated column, it didn't ask me which table, but there's no need for a calculated column to ask me which table because I'm physically putting the calculated column in the table, right? So it doesn't need to ask that question. But when I do a SumX, it needs to ask because it's ambiguous otherwise. And so it says, which table? Well, because this calculated column, this SumX is just like a calculated column, I'm going to put it in the sales table. And then this is the formula that was my calculated column, right? So that's it. That's the most simple, almost the most simple SumX function that you can write. And when I write that, it's valid syntax because these are no longer naked columns because they've been wrapped inside a function that turns those multiple values into a single value. And when I come back to my visual, so there's total sales. Here is my total sales calculated column. And here is my total sales SumX measure. And you can see that they return exactly the same number. And they do exactly the same thing. And so this is the concept that I want you to take away is imagine a SumX is just like a calculated column. So if you don't know what formula to write for your SumX, then jump over to the sales table or whichever table you're writing, get in here in the calculated column, write your formula so that it works. Once you're comfortable, you can copy it and go and paste it inside a SumX, and then please delete the column, the calculated column from the table. Because the difference is that every time you write a calculated column, these numbers are pre-calculated and permanently stored inside your model, and your model will get larger and larger over time. And as you have more and more requirements, you're going to get more and more columns. So what SumX does is it gives you the ability of doing these types of calculations without having to permanently store the data in a column. It's same but better. Same calculation, but it doesn't permanently store all of these artifacts and leave them in your model. And so I've been talking about SumX, but it's exactly the same with the other X functions. So it'll be the same if I had minx or maxx. So if I came here and instead of saying SumX, if I wanted to find out what's the largest number in, if the largest combination of those two columns, I'd say maxx, and that would return the largest value and so on. So I won't do that. All right, so just let me check my notes, and I'll go back to my summary slide and just to summarize those key things. So a calculated column works one row at a time in a table, but it permanently stores the interim results. And you don't specify the table name because it's physically in the table. SumX does exactly the same thing. What's different is it doesn't store those numbers and you can't see them. This is one of the leaps that people need to take as they get into DAX, is that you need to be able to conceptualize what's happening under the hood. And in my experience, a good way to do that is to try and physically materialize these things as a column instead of a SumX, because it helps you understand what's going on. Okay, I'm going to jump over. So there's a couple of questions from Christian. So SumX and all the other X functions are working on physical tables and virtual tables. Yes. So, for example, sorry, are you asking for an example, Christian? Or I think I can perhaps answer that. Let me give you so I think Christian's point is that in this simple, where's my measure? So in this simple SumX, this is a physical table in the model, but without me going too deep, just to demonstrate the point, I could write something much more complex. I could say, step through all of the unique values of the unit price in the products table. So products, there's a list. I could step through all the unique prices in the price list column in the products table. And then for each price, add up all of the values of the sales amount for that product. And in fact, I would have to do calculate, add up all of the values, and then I might just leave it at that for simplicity. And then multiply that by the list price. So this is quite in fact, I probably wouldn't do this. I'd probably do quantity. I guess that would make sense. So what this formula says is step through all the unique values in the list price column in the products table. And for each unique value, go ahead and work out what the sales quantity were for all of those products that sell at that price, and then multiply them by that price. And so now I got no idea what this will give me, but it's a valid number. And it's actually I think that's actually that's the number here. So you can see that it's actually generating the same amount, which is, so basically in this case, the list price in the products table is the price that the product was sold for. So, but yeah, so look, there's certainly a lot more complex stuff you can do, as Christian's pointed out. And I will show a couple of other examples when I go on to the next couple of functions. Is there a best practice on when to use the X functions versus calculated columns versus calculated columns in Power Query? Yes. Look, the general rule is try and avoid a calculated column if you can. So, I mean, that's a simplistic rule, to be fair, but there's nothing you can do in a calculated column that you can't do in a sum X or an average X or a min X or something like that. And so we try and avoid them for that storage issue that I mentioned before. But there are exceptions. And so the exceptions would be, so say if I came up to the customers table, this sort of leads into another, but I'll do it in the products table. If I wanted to work out the sales of all of my products, all right, so I could put a column in here. I'm not saying you should or you shouldn't, but for illustration purposes, I could put a column in here and just use my total sales measure. Remember, this is a calculated column, and the calculated column is using the measure. And this then will tell me the total sales for each product in my products table. So there's a lot going on here. I'm not going to go into the detail about it, but I've just very quickly and easily added the total sales for each product into my table, which there may be some use cases to want to do that. Now, if I was to do this in Power Query, I would actually have to go into Power Query, join my sales table to my product table, do a left outer join, put a group by over the products, calculate the total sales and extract it into the products table. All right, so I've done a whole lot of work in Power Query, which I can very easily do inside DAX, in this case in the calculated column. So the general rule I say is if you need a column, you should try and do it in Power Query. If there are occasions when you might choose to use a calculated column instead of Power Query, and I would say that you would use a calculated column when you want to leverage a measure or relationships inside your model to do the calculation. Then I think it's preferable to do it as a calculated column. But seriously, I could, I could talk about DAX for weeks, and we don't have that much time. So, but hopefully that's helpful.
Matt, can I interrupt you and ask one more question?
Please. Yeah.
So one question, what just came from one of the audiences, like, can you tell us about different DAX contexts? Like, I know there are row context, filter context, right? So can we get some insight on that, what that is about and how that can be helpful?
Yes, I can. Can I ask, how much time do we have? So we're 45 minutes in, just so that I'm clear.
Yeah, we have got nearly 45 minutes for, including Q&A.
Okay. Yeah. Okay, another 45 minutes, including Q&A. Yeah. Okay, all right, fine. So this is, I mean, a small question, big answer. So, and I say it's a topic in its own right. I actually have a 45-minute presentation on evaluation context. It's the hardest topic inside the DAX language. And to be honest, I really don't think we should go into it in depth. Maybe I'll finish this presentation if we've got time. We could come back and talk about it. But I think a good way to illustrate the complexity is that I'm in the products table here, right? And I've put this measure, this total sales measure, as a calculated column in the products table, and it's telling me the sales of each product. Right now, if I come down to the sales table and have a look at that measure, the formula inside total sales is this, sum of the extended amount. Now I'm going to copy that formula, Control C, I'm going to go back to my calculated column. And instead of putting the measure, total sales, in there, I'm going to put the formula, sum of the extended amount, okay? So, but you saw that this formula is inside the measure. When I use the measure, this column tells me the total sales for each product. But when I use the formula, sum of extended amount, that's not what happens. When I use the formula, sum of the extended amount, I get this number here. This is the total sales of the entire database. And I got to tell you, most people, this will blow their brains, because most people would not expect this to happen. And this is the window onto the topic of evaluation context. And so I think I'd like to park it there, because it is a complex topic. But this row, I call this row by row evaluation, right? So when I write a formula like this one, it gets evaluated for every row in the column. That's technically called row context. I don't like the term row context, particularly for beginners, because I think it's overly complex. The term is complex. It's a scary term, row context. I call it row by row evaluation. And the key thing to note is that this measure gets executed for every row in the column. That's what row context is. Filter context is something completely different. And what I showed you before with that 29 million is sort of a window into the complexity. But I seriously don't have time to get into it in any depth. So I'm sorry, I'm sort of batting that one back a bit.
No problem, Matt. Thanks. Thanks for that.
What I can tell you is, if you go to my blog and search for what was it, Microsoft Data Insights Summit, MDIS, I think that's what it was called. Microsoft My MDIS presentation. So this is back in 2017. This presentation here. So I made this presentation, 5 years ago at one of the Power BI conferences. You can see my old version of my book. And this session is on evaluation context. So that's the way to learn properly, if you watch that session. And if necessary, come back and watch it again. So just search on my website for MDIS, Microsoft Data Insights Summit, and watch that presentation. I would do you more justice by letting you watch that and doing a good job on the topic today than to try and cover both.
Thanks, Matt.
Okay, great. But it's a good question. It shows that you've got the right interest in the DAX language. So very good. All right, so I think we've covered the SumX summary. So takeaway from this session, SumX is just like a calculated column. So if you can't work out what to do with the SumX, do it as a calculated column first, then you can turn it into a SumX or an average X, min X, max X, and so on. Okay, so the next function, I've got two more that I want to talk about, building on this concept, is the filter function. And a filter function is also a bit like a calculated column. I want you to think a bit like a calculated column, but it goes to the next level. It's not only is it a calculated column, you can also think of it as a table or a virtual table. And it gets this concept of lineage, which I'll explain when we get into this. All right, so back into my demo, I'm going to come over here, and what I would like to do is I'd like to write a measure. Now remember, a measure returns a single value. And I want to know how many large customers do I have. So I'm going to put my measure in the customers table. And my formula is going to be total large customers. Now, there's various ways of writing this formula, but I'm going to use calculate. So calculate is the only function that can manipulate filtering behavior. So calculate is a bit like SUMIF. it's only a loose comparison, but you can conceptually think of it like sum is. It says, go and do this, but only for these particular items. So calculate is now I always say the only function. There's a couple of caveats. There's another function called calculate table. Calculate returns a value. Calculate table returns a table, as you might expect. And then there's also a few special DAX functions that don't seem to have calculate involved. So I'll give you an example. There's a function called total YTD. This function will manipulate filtering behavior, but there's no calculate involved. And that's because this function is what we call syntax sugar. You might have heard of this before. Syntax sugar. And so what the developers have done is to protect people, particularly beginners, to protect beginners from complex DAX formulas. They have written some special functions that use calculate, but it all gets done under the hood, so you don't have to see it and you don't have to think about it. And so, but believe me when I say that if you're going to manipulate filtering behavior inside a measure, you have to use calculate. And so I want to calculate the total customers. Now, I don't have a measure for total customers, but I could count how many rows there are in the customer table. So if I counted how many rows there are in the customer table, that would tell me how many customers I've got. So what I need to do is, before I calculate how many rows in the customers table, I need to put a filter. And the filter that I want to use, I'm just going to write this in pseudocode. I basically want to put a filter that says, just keep the big customers. All right, that's what I want to do. I want to put a filter inside the calculate. So calculate always does the filter portion first. So calculate will apply this filter. Then after the filter is applied, it will come back and count how many rows in the customers table. Now, I'm not going to fix this formula at this point in time. This is not legal. I'm just sort of trying to show you conceptually what I need to do. All right, so the next steps, therefore, are how can I filter the big customers? That's what I want to do. So what I'm going to do now, I'm going to come over to the customers table and I'm going to add a new column. So remember, this is a calculated column. And I'm going to do the same as I did in the products table a moment ago. So I'm going to say, I'll just call it column equals the total sales measure. Now, this is context transition happening here. So this relates back to the earlier question. There's a row context and a filter context. Context transition has been triggered, and we've calculated for every single row in the customers table, this is how many sales there are. So now let's say I define a customer as they're large if they've got more than $2,000 worth of sales. So I could come here and put a filter is greater than or equal to $2,000. Okay, so I'm putting a hard code on my new column. And when I put that hard code, notice that the table is now filtered and there are 5,920 customers. That's how many large customers I have in this data model or in this database. But in order to work that out, I had to physically generate a new column, and then I had to physically put a new filter on that table under the hood. So that's a bit inefficient. So I'll remove that filter. And instead, what I'll do is I'm going to turn this column, instead of returning the total sales, I'm going to turn this into a true-false statement. And so I'm going to say total sales greater than or equal to 2,000. So instead of using the filter dropdown, I'm hard coding the DAX formula and turning it from the total sales to true false. So this will now, so notice here 8233, 8207, 202, 109. So when I hit enter, instead of getting the actual sales, I'm now getting true, true, false, false. Okay, so I've turned that column into a true, false column. And of course, I could come back in here. I could put a filter on true. and I get the same number down here, right? 5920 is the total number of large customers. Okay, so the first thing I want you to take away is I could manually put a new column in my customers table. I could turn it into true, false, and I could use that inside my measure. So that would be one way of doing that. But I'm going to do something slightly different. What I'm going to do is I'm going to generate a new table. So I'll come up here and go Table Tools, New Table. And instead, I'm actually going to generate a brand new table for my data model. And this table is going to be called Large Customers. Now, this is DAX as a query language. Remember the three ways that I can write DAX: return a value, return a column, or return a table. And the simplest DAX query to return a table is just say, give me the customers table. The large customers, just give me a copy of the customers table. And so when I write that as a new table, clicking the new table button, it actually generates a new table in my model. And no surprise, is 18,484 customers. That's exactly the same number of customers I have in my table. And when I come over here, I've actually got a brand new table inside my model. Okay. But of course, I don't want a copy of my customers table. What I want is just the large customers. So I'll have to come back over here. And so now I can use the filter function. So I want to filter the customers table. Notice the filter function also takes the table as the first parameter, just like SUMX. The difference is that the filter function returns a table, right? At the end of the result of the filter function, it doesn't return a value like SUMX, it returns a table. It's a two-dimensional object. So it takes the starting table, puts a filter onto that table, and then returns a summarized version of that table. So I want to start with the customers table. And remember how I said SUMX is just like a calculated column? Well, what I want you to understand is that filter is just like a calculated column too. So I'm going to write that same calculated column. So total sales are greater than or equal to 2,000. And so you'll recognize this now, that this is a true false expression. It effectively is generating a new calculated column in my brand new copy of the customers table, which I generated. And what the filter function does is it keeps the ones that are true and disposes of the ones that are false. And so when I modify this formula like this, we've still got our large customers table. And when I come down and you look in it, now my large customers table has only got 5,920 rows in it. And so when I come back here, I can still see my large customers table, but this one's only got 5,920 rows in it. Okay, so, but I need to use this table inside my measure. So the next thing I'm going to need to do is I'm going to join this table into my model. So I'm going to join, I'm going to create a relationship between the large customers table and the customers table. I'm going to join it on the customer key, and I want a one-to-many relationship filtering in one direction. Okay, so now see what I've done? I've generated a new table using the filter function. The filter function generated a calculated column in the new table, and then filter automatically put a filter and just kept the rows that are true. And now I've generated a relationship, and I've put this all inside my model. And now that I've done that, I can now complete my measure. So now I can say, instead of this pseudo code that says just keep the big customers, well, I've actually got a table that contains the big customers, and I can use that table as a filter inside my calculate. And so all I do is I specify the name of the table. I say, use this table as a filter. Then after that, come back and count how many rows in my table. And so if I bring this in, There's the number, 5920. Okay, now let's take a step back. What I just did was I physically generated a new table, and I physically created a new relationship and physically joined it to the table where it came from, and then hard coded that new table name into my function. And I did that because I want you to be able to visualize what the filter function does. And so the key point being that this filter function, in this case, because I did it as a new table, I've actually materialized and stored this new table, and then I created the relationship. But if I copy this bit of code, Control C, and I come over here and I go back to my measure, and I come up here and I replace this physical table with the code, the filter function that generated the physical table, and click OK, I still get the same answer. And in fact, just to prove there's no monkey business going on here, I'm going to delete this table from the model. So now I don't have that physical table anymore, and come back here and I still get the same answer. And so what I've tried to demonstrate to you is to give you a visual demonstration of what this part of the formula does. The filter function takes a copy of the customers table, it adds a new calculated column into that new copied table, and that calculated column is a true-false column because I've evaluated the sales against the value 2000. And then the filter function puts a filter and only keeps the true. And then this entire function gets passed back to calculate. And this is the concept of lineage. There is no physical relation. I haven't discussed a relationship at all. But every time you generate a function like this, you get a virtual one-to-many relationship between this new table and the table that was used to generate the new table. All right, so that's called lineage. And every time you write a table function, like in 99.9% of the times you write a table function such as filter in the DAX language, you're going to get a one-to-many relationship. And so it's much easier to understand when I physically do it for you. The benefit of the DAX language is you get all the benefits of that physical generation of tables without physically having to generate anything. And this gives you enormous flexibility and capability because you don't have to load every single table that you might need to use inside your formulas, because you can generate these virtual tables on the fly, use them inside a measure, and have that new virtual table physically impact the rest of your model as if the table was physically there, even though it's not physically there. All right, so let me just come back and summarize with my slide. So the filter function is just like a virtual table with a calculated column. I've demonstrated that as a physical table. It's not materialized, which gives you a lot of power. You get the virtual table, you get the calculated column, you get the filters applied, and you get that concept of lineage without having to physically generate anything at all. And it all happens in super fast time because DAX is a very efficient language. Having said that, you can write bad DAX. There's no question about that. But yeah, it's a very powerful tool. All right, so let me take a breath and see if there's any questions, Pragati.
Matt, I will go on from this time. Actually, there was no question, so we can go on.
Okay, good, no problem. All right, so that's the filter function, and then the last function I wanted to talk about was the all function, and I want to, any function that returns a table behaves the way that I just described, but I want to just talk about the all function. and I'm going to do this inside DAX Studio just to demonstrate one more point. So here's DAX Studio. I might just be able to zoom that up this way. And I'm going to write a filter function. Now you understand what's going on. So I'm going to filter the customers table, which is exactly what I just did. And I'm going to put a filter on, it's exactly the same as before, total sales greater than or equal to 2,000. Now, you know what's going to happen when I run this, because DAX Studio is a query tool. It must return a table. And so when I run the filter function, I'll clear the cache and it's going to generate that table. And so it doesn't appear, oh yeah, I can make that smaller. So what I've just done is I've basically generated this table. And if I look down, right down in the bottom corner here, you can see this new table's got 5,920 rows in it. So it's exactly the same as I showed you before. Now, what I want to show you in this demo is I'm going to turn on this tab here called server timings. Now, when I turn on server timings, I'm going to clear the cache and then I'm going to run this query again. And then notice that there's a new tab. And when I click on the server timings tab, I get some new information, which is very helpful. Now, some of this new information, there are these two parts of Power BI. This is another big topic, which is far too in depth for today. But there are two engines. There are two calculation engines, if you like, or two engines that are used to produce results in DAX. One is called the storage engine, SE, and one is called the formula engine, FE. And as a general rule, you want to see more work. You want to see more work happening here in the storage engine and less work happening here in the formula engine. The other thing to look out for is that this formula here, or this table query, generated two queries. You can see the first query returned 18,000 rows. The second query returned 5,920 rows. And this second query is bold. And the bold query has got this highlighted callback data ID. Now, it's beyond the scope of this session to explain in detail what's going on here, but suffice to say that this is an inefficient function inside the DAX language. Now, at least conceptually, you should be able to understand what I'm talking about. So my objective is to work out how many large customers do I have. Now, if you think about this filter function, it's filtering the entire customers table. And I know that because the results is showing me all this information in the customer table, right? Now, in order to work out how many large customers I've got, I do not need to know the phone number of every customer. I do not need to know the occupation of every customer. So at least conceptually, I'd like you to understand that when I filter a table like this, in this case, I'm returning columns. I'm grabbing columns from the database that I don't need to solve the problem. In order to solve the problem, all I need is one column containing the unique customer code. Okay, and so what I could do is I could, instead of fetching the customers table, I really want to fetch just the customer key column, right? So if I go like this is really what I want to do. But the problem is, if I try and run this, it'll throw an error because the filter function must have a table as the first parameter. That's the way filter works. The first parameter must be a table. I want to use the customer key column, but the customer key column is not a table. It's a column in a table, which is very different. And so I'm going to use the all function And what the all function does is it generates a column. So let me show you. If I come down here, evaluate all customers, customer key. So if I write this function and run it and look at the results, you can see that I've still got the same number of rows, 18,484. But instead of bringing back all those columns that I don't need, I'm only bringing back one column. Okay, and so when I take this table and I use this table as the first parameter, now I'm going to clear the cache and I'm going to run the query again and go back to server timings. I don't know if you remember the numbers before, but from memory, this one was 112 milliseconds or something like that. It's still very fast. But now it's 11 milliseconds. And previously I had 2 queries that were being sent to the engine. Now I've only got 1 query that's being sent to the engine. And if I come over and have a look over here, previously I had callback data ID, which was a warning that there's a problem. I also had a very complex statement in here, which was bringing in all of the other columns that I don't need. And so without going into a lot of depth, I want you to understand, at least conceptually, that, and I'll write this one again. So the original formula was this. So if I run that, this is relatively inefficient because I'm bringing back a whole lot of columns that I don't need. My new formula is this. It does exactly the same thing, but this one is more efficient. And the reason it's more efficient is because there's a general rule that says never filter a table if you can filter a column instead. That's a good general rule to remember inside your DAX. Never filter a table if you can filter a column instead. But inside most functions, you're not allowed to refer to a column. So what you have to do is you have to turn that column into a table by wrapping it inside the all function. That's the prime, well, it's one of the most common uses of the all function, is to take a single column and turn it into a table so that you can use it somewhere else inside your formulas. So, so here's my summary. So all is, the reason it's like a virtual table, it is a virtual table. And if you're using it inside a DAX formula, it behaves as a virtual table. You get lineage, exactly as I did in the filter example before. And it allows you to get smaller, more efficient tables by using a single column. And that can in turn make your filter functions more efficient. Look, if your functions are running in 100 milliseconds, you really don't have a problem. But today I saw a page that took 47 seconds to refresh. So it's when these problems start to multiply, you can get yourself into trouble. And so there's that general rule: never filter a table if you can filter a column instead. And you can use the all function. You can also use the values function to do that filtering. I did values a little bit earlier on. About rank X and top N at the same time. And I have to preface this with, it's not a function I use a lot, but that's not such a bad thing, because what I'm about to show you is warts and all, right? So I think I know what rank X does. I think I know what top N does, but I can never really remember. I get the two confused. And so this is a great opportunity to show you how I think when going about ranking something or writing our formula. So what I might do is I want to use rank X on customers. So I'm not really sure. So I always set up a visual when I start. So before I start to write any measure, I always set up a visual. And let's say I want to rank these 5 occupations. I don't want to use occupation actually, because I know the data doesn't vary much. So I might use country instead. I want to rank my countries. Rank X sounds like a function that might do that. In fact, I'm going to bring total sales in. So believe me when I say this, I would never start to write a measure until I have this on the page in front of me, because I can see, I can visualize the problem I'm trying to do. And in fact, if I click on this column, I'm now literally ranking my countries largest to smallest. So I even know the answer before I start. United States is 1, Australia's 2, and so on, right? Do not underestimate the benefit of creating a visual, either a table or a matrix. Put something in there to help you write your formula, to give you context for the problem. All right, so I'm going to rank my countries. And so I'm going to put it in my territory column. I'm not sure what the syntax is. So I'm going to write a new measure. And let's try that again. I'm going to write a new measure, and I'm going to call it country rank. And I'm going to use IntelliSense. IntelliSense is my friend. Rank X. Okay, hit tab. Right, now I'm going to look at the syntax before I do anything else. So rank X takes a table as the first parameter. Then it has an expression and some other optional parameters, which I'm pretty sure I don't need. And also, the key things, it takes a table as its input. And secondly, it returns the rank in a list of values. So it doesn't say to me it returns a table. It says it returns a value. So remember up front when I said measures, columns, tables, you must understand your function. What does it return? Does it return a value, or a value or a table in this case? And so this one returns a value. Okay, so which table am I trying to rank? So have a think about this. Which table am I trying to rank? Well, I know this data better than you, but I'll let this go to error, and then we'll go and have a look at it. So here's the territory table. So the territory table has got a country column, but the country column is not the lowest level of granularity, right? So if I wanted to rank the territory table, I would be ranking it based on the territory key or the region, because you can see here the region is the same level of granularity as the territory key. I can see that down the bottom, right? So it tells me there's 11 rows in the table, and the territory key column has got 11 distinct values, and the region column has got 11 distinct values as well. So let me go and change it out, because I want to build on this concept, right? So if I bring the region in, and I'll change this from country rank to region rank. Now it's saying what table? Well, it's easy. It's the territory table. And it's saying, what's the expression? Well, I want to rank them based on sales. So I'm just going to use my total sales measure. All right, so let's hit enter. We'll put it in the visual and have a look. Okay, now this might not be expected. I might be saying, well, I didn't expect that. But the thing is, if you don't put the measure in a visual like this, you've got no way of knowing whether it's working properly. All right, now I'm going to explain to you why this formula is not working. I've got to say to you, first of all, I did not expect that to happen. But it's very common for it to happen. And I make that mistake all the time. The difference is I've got enough experience now to know what the problem is, and I'll explain it to you. So let's talk about this cell here. Where's my red? Let's talk about this number here. How is this number calculated? The way this number was calculated was that, first of all, there was a filter that's been applied to the model. In this case, there's been a filter put on territory region is equal to Australia. That gets done first. And then after that filter is put on Australia, then the formula gets executed. All right, so filter from the visual first, then the formula gets executed. Now, when you look at this formula, you might be saying this is the territory table containing 11 values, but no, that's not what it is. This is the territory table after the filter has been applied for regions equal to Australia. So this is not a complete copy of the territory table. It's a filtered copy of the territory table. It's been filtered by the visual. Does that make sense? And so another way to, I love doing test measures. If you don't understand, write a test measure. If I could do something like this, count rows of the territory table. All right, so I won't change the name. If I do count rows of the territory table, you can see that it returns 1, 1, 1, but when we get to the total, it's 11. That's proof that the territory table has been filtered by the visual. When we get to the total, the territory table has not been filtered by the region. So hopefully that makes sense. All right, so back to the problem at hand. So the reason I'm getting 1, 1, 1 all the way down the table is all the way down the visual is because I'm comparing a table containing one value, which is the Australian territory, against itself. Australia always will rank 1 when compared against itself. Right? And so what I need to do is I need to remove the filter from the territory table. So I go all territory. And in this case, what the all function is doing is it's removing the filter that the visual is adding. So when I write this, then I get the expected result. So it's the same function, but because the visual puts a filter, in this case on the region column, I have to remove that filter. Otherwise, I'm going to be comparing the sales against the only territory that I'm comparing it to. So that's why you have to write it like this. And then it doesn't matter which order I do this. I can sort them in alphabetical order and the formulas are still going to be correct, right? Okay, so back to the original I had, which was not to do it by territory, but to do it by country. So if I bring country in, then I'm going to get different behavior. And so I would change this formula now. So this would be country rank. Now this time I can't use the territory table because the country column is less granular than the territory table. So I say all territory country. So remember before I said never filter a table if you can filter a column instead. And so this generates a new virtual table containing all of the unique countries in my territory table. And when I do that, it should give me 1 through to 7 or 1 to, I thought it was only 6, but if I sort this, interesting. Okay, yeah, of course. So NA ranks number 7. It's got no sales. I'm guessing this is one of the optional parameters. Yeah, I'm not really sure. I'm not going to go down that hole because I don't really know what they are. If I wanted to know what those optional parameters are, I'd probably go and look online at the online documentation. All right, so that's what the rank X function does. And I sort of alluded before that there's another function called top N, and they sort of seem to do the same thing, but let's have a look at the top N function. So if I do a new measure, this will be, I'll call this top N test. Now, same process as before, start to write your formula, and then IntelliSense is your friend. Okay, so top N takes a value, so that's the N value. So if I wanted the top 2, okay, and then it takes a table, but importantly, it returns a given number of top rows. Actually, this is a very bad piece of information because the top N function returns a table. This should say returns a table containing the top rows in a table. And because it returns a table, you're not allowed to put it into DAX. So if I said, say, top end of the, so give me the top maybe 2, and the table would be, let's say, the territory. I'm not sure. If I try and write this is not valid DAX, because this is a table, and I'm not allowed to use a table inside a measure unless I somehow turn that table into a values. And so what I would have to do is I could, because it's a table, I could do something like count rows of the table. And so what this would do, now this is not going to give me anything interesting, because the top end function keeps the first 2 rows in the territory table, and then I count how many rows. Well, the answer is 2. I'm assuming this is going to just give me 2. It's giving me 2. Oh, this is interesting. So if I jump over to the territory table here, so the only country that's got more than 1 row is United States. So if I keep the top 2 rows of this column, United States is the only one that's actually got 2 rows. All the other countries have only got 1 row. And that's what's happening here. So I'm getting this top end is returning 2 rows for United States, and it's only returning 1 row for the other tables. Now, there must be some way of specifying how do I value these top ends. I don't know how to do it, to be honest. Not sure if my IntelliSense is working. Order by expression. So that's if I wanted to order it by total sales, that's where I'd bring total sales in here. And then this will basically return a table containing the top 2 countries. I want to try and turn this into something that's a little bit more meaningful. So what could I do here? Okay, this is what I'm going to do. I'm going to go to the top the top 2 products. That'll do. Just let me reset up my visual, and then I'll wrap up. So I'm going to bring product category. So remember, set something up to give you some context. Here's 4 categories. And what I want to do is I want to know what are the top 2 selling products in each of the categories. And so in my products table, I've got a column called product name. I'd like to know the name of the top 2 selling products. So this is a little bit more advanced, but what I don't want to count them, but what I'm going to use is concatenate X. So concatenate X, why is that not helping me? Concatenate X takes a table as the first expression, and in this case, my table is going to be the top 2 products, the top 2 rows in the products table. I'm not going to optimize this. And then I'm going to extract the product's name. And if I've got more than 1, which I should have, I'm going to concatenate them with a comma. So let's see what that does. Oh, that's far too many. Oh, no, this is not far too many. Okay, so instead of doing a comma, I'm just going to use a tilde, because it looks like some of these products have got, I'll do a couple of tildes here, because some of these products have got commas in their descriptions. So you can see for bikes, the top 2 selling products are the Road 150 Red and the Road 150 Red 48 and the 62. Same for this one. But this components is giving me a lot more than 2. And the reason is that, in actual fact, I don't have any sales of components. And therefore, every single product is equally in the top 2, because every single product is in the top 2, which is 0 sales. And I'm sure that's what one of these other parameters is not for concatenate, but in the top end, is what to do when you get ties. I think would go ascending And then what do you do with, oh no, I thought there was ties in there, but maybe I'm wrong. Maybe I'm confusing it with the rank X function. And obviously I wouldn't want to return every single component if there was a tie, but yeah, there must be a way of fixing that, and I'd go and have a look at the IntelliSense. So I'd go and have a look at the online documentation. So that's rank X and top N.
Thank you very much, Matt. Really, thank you for your contribution to the community. I appreciate it. Thank you very much. And I hope for everybody it will be very useful. Last but not least, if you don't mind, I'd like to ask everybody to turn on their cameras and let's take a picture for a memory, if you don't mind. Yes, hi Oakley. Nice to see you. Okay. Familiar faces, as always.
Yeah.
So I'm just going to take just 1, 2, 3. Oh, yes. Okay. Okay, I took my picture. Thank you very much. So if you have something to tell, please. If not, if you don't mind, let's end our session.
Okay, thanks everyone.
Thank you. Thank you once again, Matt.
Okay, bye.